All right. Welcome to the new SIG VMware meeting. Today is May the 10th, and we're here. Steve and I will run this meeting. For the sake of everybody's privacy, we're going to say that this meeting is being recorded and will be published on YouTube. So if you don't feel comfortable in being recorded, please drop off now. Otherwise, you will be posted online. And with that out of the way, I'll hand it over to you, Steve, for the first part of the meeting.
Okay. Do you want to just open the agenda doc, Fabio, or do you want me to do it?
Let me see. I can definitely do it.
And then I posted that same doc in the chat link. So what I was going to cover was the here. I got to get the doc on myself.
Okay, let me share my screen here. Okay.
So last week was KubeCon Europe. It was a huge event. The attendance was triple what it was at KubeCon in Berlin last year, and slightly bigger than historically the US KubeCon has had greater attendance, but this surpassed the attendance at KubeCon in Austin, I'm told. A lot of sessions, like I believe in excess of 200 of them, probably 300 if you counted each individual lightning talk. I'm not going to go into each one, but if you look at the agenda docs, there's a link there to the conference schedule site, and I'd say at least a third of the speakers uploaded decks. And then the CNCF recorded presentations from, I believe, all the sessions at the main event. It didn't look like the Contributor Summit event had posted recordings, at least on that YouTube channel. But anyway, I'd encourage you to look at those. There's really just so many of them that it's hard to go into details, but I think many of the people on this call were there. So what I'd like to suggest is maybe of the people in today's meeting who attended KubeCon, perhaps everybody can nominate their favorite session or even two, just to give those who couldn't be there a little guidance on maybe where they should spend time looking at those recordings and uploaded decks. To start things off, I'm going to say that my favorite session was the Michael Gash presentation on considerations for resource management when running KubeCon on a cloud provider, including vSphere. And I learned a lot. The deck's very good. I mean, even without looking at the recording, you can get a lot from the deck. And this isn't just me saying so. The guy who's currently the lead architect on Kubernetes, Tim Hawken, came up to Michael after that presentation, thanked him for it, and said it was one of the best sessions he had seen. So I think that the nomination of that particular session as a good one is pretty widespread. Fabio, I know you were there. What was your favorite session? And maybe we'll invite some of the others after you.
I think probably my favorite session were the one that we're talking about, all the new stuff on the networking side. So more like Envo and Istio. So I've seen actually a few of them. Very interesting because it's a different take on of a age-old problem, which is observability in network. And this new projects bring pretty much everything to a different level, and it's very interesting to see because the approach they're taking is very application oriented, which is very interesting, and there's a lot of innovation going on in that space right now. So
was there anyone in particular? Because I know I looked at the session categories and kind of the hot topics based on the number of sessions on the subject. Istio was up there, as well as machine learning, and I think security as well.
There's one particular talk that was a joint talk between Google, VMware, and I think it was IBM. It was on performance on Istio. And it was very interesting because it had a very nice visualization of basically the traffic flow using Istio. It was very interesting because of the performance implication of using something like Istio compared to like straight L3 or L2 networking.
Yeah, I'll have to catch that myself. I know I went to Open Source Summit and the Scale Conference where that was talked about. And as I recollect, there were some people who expressed concerns that Istio running in user space does incur some limitations, so that if your app demands running the network at full wire speed, at least with today's technologies, that may not be possible. But it does offer some great operational efficiencies. And I think a large part of the Istio feature is that it allows you as an app developer to delegate a lot of this hard work regarding networking off to this other thing that handles it for you. So writing an app becomes much simpler with Istio than it would be otherwise.
And thanks, Tim, for digging up the link to the recording. That's very nice. Actually, I would use it myself. Is there anyone that has a favorite talk that want to suggest to other people to watch about KubeCon?
And Steve, the one that you mentioned also, it would be nice if you could drop a link to that in the minutes.
Okay, I'll do it. I'll start looking for it now while I'm listening. Unfortunately, the playlist with 300 recordings doesn't appear to be sorted in any order I could fathom. So it is kind of hard to find one in there. Anyway, what was your favorite session, Tim, if you had one?
Well, I would actually probably say the new contributor track at the Contrib Summit the day before the conference, just because I've been really keen on things that are helping to enable all of the newcomers, like, for example, all the engineers that I work with day to day who are just starting to become interested in open source and Kubernetes and engage. So a 3-hour track on how to do that in this community and be an effective developer in this space, I think was really useful.
Yeah, I was there and I'd second that. And that contributor summit split into 2 parallel tracks. And I was hoping to go catch the one that I didn't go to because it was a close call on choosing which one. I don't know that, as of 2 days ago when I first looked, I couldn't find a recording of that, however.
It is not up, or it was not yesterday, but it is coming because it's a big, long section. They're working on getting it broken down into pieces and sort of indexed with a table of contents so it's more approachable.
Okay, that's good news. And even the individual SIG decks, I think, are accessible, but the actual main track decks didn't seem to be up as a few days ago either, but I'm hoping those, we can put those in the notes for a future meeting because I think those were both valuable for people who are considering getting actively involved on Kubernetes as contributors.
Totally agree. Let's move forward with the agenda.
Okay, so I'll turn it over to you, Flavio.
Thanks. The next item on the agenda, we have a couple of updates on the project that we have active. Right now, there's a cloud provider working group, as many of you are aware of. This cloud provider working group is actually very active right now, and a good part of yesterday's meeting was spent on the proposal they have to create a SIG provider, which will basically include all the cloud provider sub-projects for various different SIGs under a single SIG umbrella. So we discussed that proposal. They're moving forward a proposal, but the proposal itself in its very early stage, and given it's a very debated topic, it's not something that will probably be merged in and accepted and created in in a reasonable amount of time. There's going to be some discussion going on, so it's going to take a long time. So for what concerns the vSphere cloud provider, we're moving forward with the design phase. So we're working on creating the design document for the cloud provider itself. So for the out of the 3 cloud provider, and we're going to have that ready in the 1.11 timeframe. For 1.12, we'll start doing the actual implementation. So we have a document out there that is linked in the previous meeting notes here. If you want to sign up to do some work and help in the design phase of this, you're very welcome to sign up for it. We're going to start having our weekly meeting starting next week. So I'm going to send out something on the Slack channel, some sort of poll to figure out what's the time that works best for most of the people. And we're going to start having those meetings starting next week. Well, that's pretty much it for that. There's another update on virtual kubelet work, and Ben is here to give us some news around that. Over to you, Ben.
Thank you. I should give some background on this because it's the first time that we've talked about this in this group. So we've been looking at how we might bring the concept of a pod VM into the vSphere pod VM into the Kubernetes space. And what is a pod VM? Well, we've had this project called vSphere Integrated Containers for the last 3 years that creates container VMs. A container VM is basically a container that's strongly isolated inside of its own VM. And architecturally speaking, it's not that each VM runs a container engine and starts a container. Each VM basically masquerades as a container. So rather than having all of the dependencies needed, like container D or run C or even Docker running inside each VM, we literally extract the container image to a VMDK, attach a VMDK to a VM with a minimal Linux kernel that's like 25 meg on an ISO, and then we boot the VM from this ISO, chroot into the root file system on the container image mount that we've created, and then the VM just becomes the container. Now, Vic, as I say, it's pretty mature. It's been out for a few years. Customers are mostly using it as a means to get containers quickly spun up into vSphere in a manner that sort of fits with the way that they're used to running VMs, right? Because if they can see a container running and they can monitor it and manage it, and view it and trust it in exactly the same way as to do with their existing VMs, that's a big win for particularly for long-running stateful workloads, which actually a lot of our customers are using containers for. So we have this concept of a container VM. Now the container VM runs inside. Is that a question?
No, sorry.
Okay. Okay. So the container VM runs inside of what we call a virtual container host. Now, given that the container VM is a first-class citizen in vSphere, this idea of a host, container host, has to be something virtual because there's no Linux host that these containers run in, and that's an important distinction between a VIC container VM and a regular container, because a VIC container VM connects directly to vSphere infrastructure. It connects to vSphere storage, vSphere networks, and the vSphere control plane. Whereas a regular container connects to Linux storage and Linux networks and the Linux control plane. So there's a big distinction there. So what is a host in this context? Well, in the vSphere world, a host is actually a resource pool. So you can basically, when you create a virtual container host, it stands up a VM that represents an API endpoint for you to connect your Docker client to. That API endpoint contains a whole bunch of information, metadata, basically about your authentication credentials and the memory and CPU limits you might have, and the data stores that you can create volumes to, and where your images go. And that's basically, as a client, that is your your portal into vSphere with respect to being able to create containers. So a virtual container host is not a resource reservation in the way that a big Docker host is. It's simply an API running in a VM with a theoretical resource that has DRS backing it. So if I then create a container using Vic, it'll create a VM. DRS will decide where that VM goes, which host that VM goes onto, and it will then start that container running. Now, the fact that there's clustering and scheduling happening behind the scenes is completely transparent to the user. The user just sees some amount of resource, and if they do Docker PS, they'll see the containers that are running. If they do Docker images, they'll see the images that are there. So from the client, it's completely transparent, but in vSphere, it's able to use this concept of a virtual container host to be not only very highly multi-tenant without needing resource reservations, but it also allows for all workloads running from different tenants to be very strongly isolated from each other and from the control plane. So as we're looking at what this means for Kubernetes, inevitably we're looking at this and saying, okay, well, we think there may be some real value in a strongly isolated pod concept. And we've been experimenting with that and doing a whole bunch of work around that. Now, of course, we're not the first to look at that. There's the Carter project that's looking at that. There's various approaches to this whole idea of a strongly isolated pod. The vSphere approach is somewhat different because vSphere is a type 2 hypervisor. It's either type 1 or type 2. It's different to Carter. I can never remember which is which. vSphere is the kind of hypervisor where VMs are very strongly isolated from the host they're running on, and the host they're running on just runs VMs. That's basically all that it does. Whereas in the Carter model, where they typically use KVM, it's a different model because really the container and a container and a VM can kind of run side by side in that model. And a VM should really be considered like a specialized container, or you could say a container is like a specialized VM. Ultimately, they're sandboxes within a guest operating system that use different abstractions and have different capabilities. But the fact that they're all running inside of the same guest operating system means that the Carter model is still this idea of a node, a fixed node that's a Linux guest, and inside of that node you run VMs, and the VMs encapsulate the pods. Now, in vSphere, because we're a different kind of hypervisor and because we already have this clustering and scheduling built in, this concept of a fixed host that actually runs VMs inside of it just doesn't work. That doesn't fit with our model. So instead, we need to think about this concept of a virtual container host in the context of Kubernetes. So, if you were to extrapolate that, it might make sense to think about a virtual node, right? So Kubernetes sees a node, and it's not literally a node that is a guest operating system. It's a node as in some amount of resource in vSphere into which pods can be deployed. If you change that concept, though, and you say, okay, well, a node now isn't a literal node, it's in fact a virtual node, many of the things that kubelet assumes are potentially broken, right? Kubelet assumes all sorts of things. It assumes that there's a guest file system into which the containers are writing their logs, and that it can read those logs out of that guest file system. It assumes that it can bind mount secrets into pods. It assumes that it can modify resolve.conf to set DNS properties. There's so many. Kubelet is designed specifically to be a guest agent that represents a pod. Sorry, that represents a node. To modify kubelet to remove all of these node-like, all these guest agent capabilities, or all these guest agent assumptions, kind of goes against what kubelet's designed to be. Kubelet is designed to be a guest agent. That's what it's for. So this is why we were interested in the virtual kubelet project, because the virtual kubelet project is designed to do exactly that. It's designed to take a step back and say, okay, well, maybe a node isn't a literal node. Maybe a node is something else. And maybe we should consider abstracting at a higher level than the CRI interface, and saying, okay, let's talk about pods in the abstract, or let's talk about services in the abstract, or let's talk about, or containers in the abstract, rather than talking about things, in literal terms like, roots or DNS or literal containers. It talks about things more in the abstract and leaves it up to, it's got a plugin mechanism, and it leaves it up to the particular provider to decide what actually, how does a pod manifest, right? How is the networking manifested? How is DNS handled? How are all these things handled? So we've been looking at that for some time now. Loke in the Vic team has a virtual kubelet provider that they've been experimenting with. And yeah, that's basically where we're at. I think that Loke will be submitting a pull request fairly soon to add that to the virtual kubelet project. I would say that there's a lot to be said about virtual kubelet in terms of its architectural intentions. I think it's fair to say that there's some debate within the Kubernetes community as to whether virtual kubelet is the right abstraction for this approach. And I think it's a really good question. It's a question that we're going to be going to SIG architecture to discuss. My opinion is that virtual kubelet can serve two purposes. It can serve the purpose which Microsoft and Amazon are using it for, or have designed it to work with. And the use case is, I want basically some compute that is theoretically infinite, into which I can burst at any point, right? So I might have a cluster that's running some things, and the things that my cluster is running are relatively static, and I know what they need to do, but maybe I need to just run a huge batch job, or some big data job, or some analytics work, and I just want to pay to run that stuff for the period of time that I need to run it, but I don't want my cluster to be so big that it just, that I need this all the time. Or maybe, I have a very bursty workload and I want to be able to very rapidly burst into the cloud, and it's too expensive for me to maintain nodes 24/7 to potentially burst into. Rather, I'd like to pay on demand when I'm bursting, right? There's these various different use cases that Amazon and Microsoft have come up with. And those are very valid use cases. I think that we will be, I think it's going to be very interesting to think about what nodeless means, or what containers as a service means within the context of Kubernetes. And I think there's a lot of discussion and thought that needs to go into that. Now, nodeless as a concept is more of a consumption model than it is an architecture, right? If you want to consume Kubernetes in a nodeless manner, well, that would just be an abstraction on top of one or more Kubernetes clusters that ultimately sit underneath and provide the plumbing required for you to have this nodeless experience. So it's not necessarily that Kubernetes has to change to support nodeless, but the idea of consuming theoretically infinite resource in a manner in which you pay, for what you use, has some very strong arguments, and this is where a lot of the cloud providers are going. So the debate right now is really, okay, there's obvious business value to that, there's obvious economic benefits to that, but is having this infinite node that represents potentially multiple fault domains and whatever else, is it better for that to show up as a node in Kubernetes, or is it better to have a different approach to that hybrid model? So a different approach, for example, could be that you have a nodeless API or some kind of nodeless abstraction layer. So you could have let's call it a nodeless cluster, even though that's kind of a nonsensical way to describe it. But let's call it that, a nodeless cluster. Now, if you were to federate a nodeless cluster with a regular cluster, you would still get that hybrid model, but it might be a more natural approach, because the regular cluster isn't seeing the nodeless interface as a node, right? Because the problem with seeing a nodeless interface as a node is that, for example, like a daemon set just doesn't make sense for the virtual node, right? It doesn't make sense necessarily to have you can't run privileged containers on the virtual node because that doesn't make sense. There's no Linux API, so there's things that I think that are jar with people a little bit in terms of it showing up as a node. So there's definitely still some debate to be had around the sort of high level architecture of and the long-term way that we think about nodeless. But in the meantime, I think virtual kubelet is obviously delivering some business value to customers. Customers are already using it for various different use cases. I think it's a decent interim solution. And the way that we're using it is more, I don't know. It's, I'll stop waffling there. I have a lot of thoughts about this, and my thoughts are still evolving. But that's kind of the background to why we're involved in it, what we're doing, and what's going on.
Yep, it's a very interesting explanation. So I was wondering, what are the next steps now? I mean, I know that you guys had a face-to-face meeting a few weeks ago.
Yeah. So as a project, it's still pretty immature in that there's quite a few features that are not there that really need to be there if it's going to do what it needs to do. And one of the tasks that we did a couple months ago was to do some analysis work where we said, okay, if our goal is to be functionally complete with kubelet, what are all the functional capabilities of kubelet, and which of these ones do we think matter for virtual kubelet, and in what order do we think those should be implemented, and how should we implement them, right? So actually, rather than just kind of hand waving and saying, okay, well, let's just add features as they're needed, to actually have a roadmap and a plan and some real thought about, what makes sense to implement. That's what we spent a couple days doing 2 weeks ago, and it led us to a whole bunch of GitHub issues that that represent things that should be added, and yeah, we're going to be gradually working on that.
Well, so there's like a roadmap of things that you guys have to accomplish. And
I think the highest priority items are items that that might impact the provider interface, because ideally you want to get to a point as soon as possible where you don't have churn in that. So there's a few things that I think it's pretty clear would affect that. And at the end of the day, it's not it doesn't make sense for it to be a project in which you attempt to rewrite the kubelet code base, because there's just no point doing that. The only way that virtual kubelet makes sense is if you acknowledge that all the providers actually have quite different implementations for many of the control loops. So things like garbage collection, for example, image garbage collection or container garbage collection. You might have a common control loop that looks to see, okay, well, I'm going to maintain a certain number of containers, or a certain number of stale containers, or a certain number of stale images before I start pruning things, or you may just leave it up to every provider because they might have completely different needs around garbage collection. So I think they're on the right track, and I think it's good to have a roadmap. It's good to have a plan, and we, as I say, we have Microsoft and Amazon and VMware bought into moving it forward, and I think that the implementation work that we're doing and the sort of architectural discussions that are happening with the community are inevitably going to happen in parallel. And we'll see what comes of that.
Great. Thanks, Ben, for this update on virtual kubelet. Well, let's move forward with the rest of the meeting agenda. We have a demo on the GPU support on Kubernetes and vSphere. Hui, are you able to present? You should be able to share your screen right away.
Yeah. I'm going to share my screen. Can you guys see my screen?
Yes. All right, so yours.
Thanks, Fabio. Hello, everyone. here I'm going to demo the GPU support with Kubernetes and the vSphere. So the goal of the demo is to show you the exact steps to bring up a Kubernetes cluster with GPU support on top of vSphere. So in order to accomplish that goal, we need three parts to work together. The first part is the vSphere is able to expose the GPU to the VM. This is the major part. The second one is we need NVIDIA support to be able to expose the GPU resource to the container through the NVIDIA GPU driver and the NVIDIA container runtime. The third one is we also need the Kubernetes support. Kubernetes had this device plugin architecture to be able to expose the GPU resource to the cluster. So here's what it looks like overall in this setup. So we have a physical server which has a NVIDIA GPU. In this case, I'm using the NVIDIA Grid K1 GPU. The board has full physical GPU. With that, I'm going to have the ESX 6.5, and then I'm create VM. I'm going to create 3 VM, 1 master VM, the 2 worker nodes VM. I'm going to attach GPU to the two to the 2 worker VMs. On top of that, I create Kubernetes cluster and expose GPU resource to the device plugin. And with that, my cluster is ready to deploy and run the machine learning workload. So I'm going to demo how to run a TensorFlow workload on top of that. If you guys had any question, feel free to stop me. So first, let's look at what is the vSphere support of GPU today. vSphere supports 2 modes in terms of exposing GPU to the VM. The first mode is called direct parse IO, the parse through. Basically, it's let the VM to fully bypass the hypervisor, so it has the best performance. And it's allow each VM has 1 or multiple GPU. That's also it support a wide range of GPU hardware. It's called both NVIDIA and AMD. The second option is the NVIDIA vGPU option. So NVIDIA vGPU basically able to divide the physical GPU into multiple virtual GPU, and it's basically managed through some profile. So the GPU frame buffer can be divided into multiple pieces, and each vGPU will not share frame buffer in this way, but they're going to share the compute units. So for example, if we look at the NVIDIA V100, and it has a 16 GB frame buffer, if you want to support like a 16 graphic VM, and each VM got 1 GB frame buffer, but all of them going to share the compute units, and the NVIDIA has its own scheduler, and it's going to the scheduler going to make sure each VM get a fair share of the resource, the compute resource. But from here you can see that if your workloads require a big size of frame buffer, then you don't want to do too much sizing and divide. So you may want to fully let the VM fully occupy the GPU. So NVIDIA has a fully support of both container and also the Kubernetes. So the requirement is you have to install the driver, a certain version of driver, and also you have to install the Docker runtime for NVIDIA. And also you need to deploy the device plugin from NVIDIA to make all those things work. And let's look at the Kubernetes support of GPU today. The device plugin has been beta since 1.10, and GPU is one kind of extended compute resource. And it is an integer resource, means you can request and allocate resource based on just integer number like 1, 2, 3. For today, Kubernetes only supports GPU in a homogeneous way, means it treats each node with GPU basically the same. If your two nodes has two different kinds of physical GPU, basically Kubernetes just treated the same. So you request one GPU from one node, is the same as you request from the other node, but the underlying physical may be different. So Kubernetes doesn't differentiate them today. And actually, how to address that has been discussed in the SIG. So a lot of discussion on the work group resource management, and also work group machine learning, and also some scheduling discussion also happened with Signal. So with that, I'm going to demo. This is a recorded session, and I'm just going to walk through that. So first of all, assuming you have the physical server and you got the GPU installed on the server, so now I just need to install ESX. In this case, I installed the 6.5 GA version. And now I'm going to use vCenter to manage the host. And also, I'm trying to configure the direct path IO for those devices. So from here, just navigates to the host, and also to host config hardware and PCI devices. So this page is going to list all the all the direct path IO enabled device PCI devices. In this case, I have 4 GPU listed here. If you haven't, you just click edit and just check the device you want to config. And if you click OK, and you then need to reboot the host after the configuration be changed. After that, your host is ready to config the VM with GPUs. So now I'm just going to deploy 3 VMs. In this case, I deploy all of them Ubuntu 16.04 version VM, and 1 for the master node and 2 for the worker node. For the master, I don't attach any GPU to it, and for the 2 worker node, I'm trying to attach GPU to it. With that, you edit the VM, and you need to add a new device. And choose PCI device. In my case, I already attached the 2 GPU, the number 45 and 47. And with that, you save the config and the power on the VM. And please verify the GPU is working fine by just run the lspci command inside the VM, and make sure the GPU will be exposed to the Linux kernel. After the VM beacon on, you got all the IP address, and I connected to the VMs through the console. Now, what I need to do is I'm going to install the drivers, the GPU drivers to all the VMs. By doing that, you just go to the NVIDIA website and get what is the latest driver version for your GPU model, and install it through the apt get. And I just ignore that part. So with that, you just verify the driver is right by just running the NVIDIA SMI command. So for here, just verify my version is the one I expected. And also, you need a Docker to install. So what I installed is the Docker 1.13 version. Because this version will be will be used by when I try to install the NVIDIA Docker runtime or the container runtime. So the next step is going to install the NVIDIA Docker container runtime. So what I'm going to do, you just need to run this command and make sure the version is correct. And with that, you have to set the Docker runtime to use NVIDIA container runtime. Edit this file and restart Docker. So with that, pretty much you have the container environment set up with GPU support. So now I just need to verify all the container is running fine even without Kubernetes. So what I verify is I use the Docker command to run some Docker image. This is the Google image, and using the NVIDIA runtime, run some TensorFlow. Run the basic Python import statement and make sure everything is fine.
Wait, just wanted to, and be conscious of the time. We have another 15 minutes left, and we have other things to discuss. So, if you have something you want to show, maybe it's better to just cut to that. Maybe give it another like 2 or 3 minutes on the demo.
Okay, good. I'll try to
Thank
finish that. So I'm just going to ignore a few steps and go straight to show once we got everything, the basic Kubernetes cluster running, what I need is just deploy the device plugin, and then I will able to see the node with the GPU capacity and also the allocatable. So what you can see here is for the two nodes I have, for this one, I have one GPU, so I can see that GPU capacity and allocatable equal to 1. And the other one, I have 2 GPUs. So with that, you're ready to actually deploy the application. For this case, I'm going to deploy a TensorFlow application to fully utilize, to use 2 GPUs. So with that, I'm going to just share some results. See that by using 2 GPU is reducing the compute time by half compared to you just using one GPU. So I only need to show that. Can you guys still see my screen? Can you guys see my screen now?
Yep, I can see it.
Okay, so here just show my jobs. The log of my job is is basically running thing by using single GPU. The computation time is 4 minutes, and by using two GPUs, the computation time reduced to 2 minutes. So that just demonstrates how the TensorFlow workload running on top of this cluster. I think that's all.
That's great. So basically, you're saying that we have all the things that we need to run GPU accelerated workloads on vSphere. We can do it today. I mean, with Kubernetes 110 and ESX 6.5 or 6.7 even.
Right.
Cool. Awesome. That was great. Thank you, Hui.
Very cool. Hui, is your demo available anywhere, or maybe you could make it available on GitHub?
I could make it available on GitHub. Let me confirm a few things in the days.
And if that deck is available too, maybe you could put a link to it in the meeting notes.
Sure.
Yeah, it will be great if you can just even, like put down some notes on this. How do you make this happen? And it will be great so people can reproduce this in their own environment. I think it's a great use case, especially with the GPU support now being in Kubernetes. Okay, let's move on to the discussion part, given that we have 11 minutes left. We don't have much to discuss this week on the agenda, but I want to open up the floor for question at the end. So let's get these two items out of the way. If you could stop sharing your screen, Hui, so we can go back to the... Thank you. So we have two items on the discussion list this week. We have one, which is deprecate Photon Cloud Provider in Kubernetes. I think Doug proposed a PR to do this. I personally think it makes sense. Photon Controller has been out of maintenance for what? I think it's 6 months now.
Yeah.
What's the context on this, Doug? I mean, I know that Photon Controller is not being maintained anymore. Is that just dead code that has to be removed?
Yeah. So it hasn't been maintained since October, and support for it has already been removed from KubeUp, the shell script deployment framework. And I just ran into it, doing some work. And, if you look at the history, it's only being touched when there's provider interface changes or build changes. And it's just kind of a burden in that way when it's not actually being used. So I guess the options would be to, remove it entirely, or after, like, I think it was probably the same day, there was another PR that came in to deprecate the OpenStack in-tree provider. So they have an out-of-tree provider already. And it was a pretty small change, but it's just a list of deprecated plugins. It prints out a warning if you're using it. So we could just do that for 111 and then look at removing the rest after 111. But I would be surprised if anybody's actually using it now at this point, 6 months.
Yeah, I'll be surprised as well. But I mean, given that the code is still out there, if I'm not mistaken, and maybe there's somebody using it, we don't know for sure. I'd rather go with the deprecation notice, like right away. I mean, as soon as the OpenStack deprecation notice is merged, and we can do the same for photon control, and then just remove it the very first chance we have. Like when people start, I mean, in-tree providers have to go anyway, and I think it's probably just more graceful just to make it market deprecated as soon as possible, and then just make it go away once people start actually removing code from the cloud provider.
Yeah, I agree with the philosophy of giving a warning first, just in case, because we're speculating that nobody's using it, but how do you know?
Yeah, especially I remember people like still asking questions in forums and whatnot. So just being on the safe side.
Okay.
The other item is still on you, Doug. It is potentially adding SAML token login to the cloud provider in 1.11. I don't know if I know there was some discussion on this in the past two meetings that we had. I know that the work on GoVMommy has been done already, and it's just a matter of trying to push this feature down, before the code freeze. If they're willing to accept this, not as a new feature, but more like an enhancement in the cloud provider.
Yeah, so we were debating if it was bug fix, improvement, or feature. And I think we had said, well, let's call it a feature and go through the process of proposing the feature. And then I went to do that on the Kubernetes feature repo, and I went to look for an example template of how these things are done. I'll post to the chat the one that I found, and the response was, well, this is entirely a vSphere specific feature. There's no need to have a proposal here. So
I guess that maybe I would suggest maybe reach out to the people involved. I remember seeing here, and here seems to be one of the coordinators in when this issues arise. So maybe just drop in a line on Slack and figure out if we actually need to go through the feature request, or if it's just a matter of opening an issue and then seeing that issue being closed because it's not pertinent to discussion as a new feature, because it's just an enhancement on something that is already there. It's just specific to us.
right.
I mean, we should be playing nice and everything, but I guess that if there's a precedent on this, and we don't want to burden the process with unnecessary requests if we understand that it's not necessary.
Yeah.
You know what I mean? Cool. Okay. Any questions on these two agenda items?
So Doug, you just posted in the chat a link, and that one is entitled Support Multiple vCenters. Is that the same issue that you were just talking
No,
about?
it's a different issue. I was just saying that I was looking for an example of a previously proposed feature. So I think that if we were to propose, adding the SAML token to VCP, that would probably get the same response, but I'll look into it.
Okay.
Yeah, I see that here is in the same thread. So I think.
I'm sorry.
Go ahead, Andrew.
Doug, couldn't you write an entire issue request about SAML token support without ever mentioning vSphere? I mean, SAML isn't unique to vSphere.
No, but I mean, the other cloud providers already have their, like Amazon's using the IAM identity, and they all have their own way of doing it. So it is, while SAML tokens might not be vSphere specific, this implementation is.
Okay.
Okay, I think just pinging here would be a good next step for this, and then figure it out if it requires a new feature or not. I believe it will not, but just have somebody else from the community have a go at that. Okay, Okay, so we're out of items on the agenda. So we're going to open up for questions, discussions, and everything else that is not on the agenda for the next 3 minutes. So if you guys have anything, feel free to chime in. All right. Looks like we covered everything we have. All right. I'm going to give you back, 3 minutes of your time this week. Cool.
Okay. Bye.
Bye, everyone. We're going to see you in, on May the 24th. So have a good rest of the week, everyone. Goodbye.
Bye, everybody.
Bye.